previously we were looking at what are the steps that we are going to take in very broad sense. Okay, so out of which we had discussed about the steps. I think we discussed well for the first, the data collection. So we don't have anything else to do in this, because for the given project we are directly collecting this, right, the house rate, right, rates directly from web. So nothing is needed as of now. We also might not require any of the pre-processing, correct? If you look at the document which I sent, this actually includes the elimination of the not a numbers values, NaNs, from the table. If at all you have any NaNs present, unwanted characters present in the list, right, we are trying to removing that. Okay, so this is the filtering process. This is what we had discussed earlier in the previous section. Okay, also if you look at the document, the update, weekly update document, you can see that there we didn't mention that we have a data set with us, because if you directly say that data is already with us, right, maybe the next update they expect you to perform the starting the pre-processing. Okay, so I have not mentioned that you already have got a data with you, right? I just mentioned that you are going to do the analysis, you are going to search their websites for various data. Okay, let's push one more week and then we'll say that okay, we have the data. All right, because otherwise they expect you to do the jobs much quicker, right, in a faster pace. And if we finish early, they might say that this work is not sufficient, this is very small work, something like that. Okay, so let's push this. Okay, initially, though I do the work from my side, whatever is required for you, but in the weekly update you are not going to tell that okay, this is what I have done this week. Don't say the complete thing. Okay, so just I'll tell you the flow in which we are going to submit the weekly update. Let's go in a normal, slowly fashion. At the end, we'll say that okay, we are doing the job. We are doing the job quickly. We are doing a lot of work now. Towards the end, last few weeks, we'll say that okay, we are doing a lot of work now, and we'll try to wind up just before the exact time. Okay, so that's the point, right? When it comes to the very last week, we'll show that okay, lot of work done now, and they'll be in a hurry to submit your work. So you will also say that yes, I'm done with the work. We'll finish. Okay, all right. So data collection and pre-processing are the two things we discussed in the previous section, right? Okay, now once the pre-processed data is there with you, our next intention is nothing but we have to build a mathematical model. Right, so in the mathematical model we have to choose one important aspect that is called as the algorithm. Which algorithm you are going to use, right? We have a variety of operations. Majorly, they are classified into two categories, right? One is called as a machine learning. Okay, the second thing is deep learning. Okay, so now let's discuss about the machine learning first. All right, what are the various options you have under machine learning? I think you studied a subject or right called machine learning, right? Right. Do you remember any algorithms you studied in machine learning? Anything that you can name? Okay. All right. Correct. Okay. Decision tree. Right. Right. Then random forest. Yes. All right, no problem. So the majority of the problems you already have mentioned over here. Okay, let me, since it's already you have studied a topic or a subject based on this, it becomes easier for us to understand. So now, what is the basic objective of machine learning, right? What's the basic goal here, right? You have some problem, you want to solve the problem by the help of a machine. So in uh, machine learning, you always try to teach a machine to solve a machine, how to solve a problem, right? Under the given circumstances, right? In the sense, you will teach the machine by training and testing. Okay, two things are there. Training will have the training data, right? And you will train the trained machine itself is called as a model, right? And once that is done, then maybe you can perform a testing phase, and in the testing phase you give unknown data to the machine, and you test. Okay, which is whichever data is not known to the machine, you have not used for what is called as a training purpose, right? You give such things to the machine. Okay, and machine should be able to classify that as required. Okay, so let's list some of the important machine learning algorithms. Okay, so you already mentioned, I think, linear regression. What was the idea here? What's the I just to recall what you have done. Okay, nothing. It's not very important that you tell everything correctly here. All right. So it's like, right, linear regression is going to deal with, right, you are trying to write a straight line between the two classes. Linearly, you are trying to separate the classes. Okay, so let's say our intention is to classify tables and chairs. All right, so the table class will be present on one side, and the what you call as the other class, the chair, right, will be present on the other side whenever you get the features out of it. So the features will be, right, plotted over some space, 2D, 3D, or multiple dimensions. And then what you do, then you try to separate the two classes by fitting a straight line. That's a linear regression. All right, so that's the first thing. Then why not non-linear lines, right? When you can draw a straight line to separate the classes, why not non-linear? Definitely non-linear is also possible. It's, instead of calling it as a non-linear function, you call it as a logistical regression or logistic regression. Okay, I think you studied this as well. Then followed by this, definitely you have studied the decision tree, correct? So if you remember what's there in decision tree, it's actually the name itself suggests something decision has to be taken, and there is a tree over there. But what's the tree doing over there? So if you have a particular point where you ask a question and you have two options, either this, yes or no. Again, reach a node. You come to another options. Like this, you keep on changing your questions at every node, and you keep getting different answers. So from there, you keep going ahead like this. Okay, so this is a decision tree, right? So are you able to recall that? Yes, fantastic. Okay, so anyway, mathematics I will not deal here because as of now it's not required for us. Okay, moving ahead. Once the decision tree is covered, then I think you mentioned about the support vector machines. Right. If you remember, this is actually a very famous algorithm in classification, right? So from a class, you try to generate a vector that points out of the class. Okay, so by using the various vectors, you try to identify which class a test data belongs to. Again, you have a lot of mathematics over there to deal with. As of now, it's not required. Okay, fine. That's SVM, support vector machines. Already you have studied the mathematics of that in the subject called machine learning. All right, followed by, I think you have a Bayes rule, a based problem. It's a probabilistic method, right? It's called as Navy Bayes, correct? You have, I think you already have studied this. This is simply using Bayes rule. There is a rule in probability called Bayes rule, right? You try to apply the Bayes rule for, right? Bayes rule basically deals with the probability. What is the probability that an event can occur provided any other condition is mentioned, right? You use a probability and you calculate a score belonging to a class. When a test object is given, right? Say the test image is a chair. Okay, so you give it to machine calculates what is the chance that this given image is a chair. Okay, and if the chair is given, the probability of this answer being chair is more compared to the given image is a table. So you get higher probability for a chair than a table because input data itself is a chair. So your answer will be a chair. The machine declares that yes, the test object which you have given now is a, right? It's a chair, like that. Okay, so the navy base. Then you have, I think, the nearest neighbor class that's called as a KNN. The K, have you studied this? Nearest neighbor. This is KNN, very famous algorithm. Then you actually, instead of using the nearest neighbor technique, you use a mean technique. That's why it is called as a K-means, right? So you try to find the various number of means from the given data set to make a classification. So when you learn that there are K different means present in your input data set, it means you are training the K-means. Okay, then I think you also mentioned about which one? Okay, random forest, I guess, correct? You told about random forest. Are you able to recall what happens over there? What was the all mathematics about? In case, yeah, if you are able to recall, please tell me. Let's quickly let's try to discuss about that, and then we'll proceed further. Perfect. Right. So instead of a single tree, you have a forest. All right. So basically, right, you have n number of training data over there, right? There are n different classes. Okay. If it was a simple two-class case, it's a decision tree. When you have multiple cases, you have multiple trees present over there. Multiple trees indicating that it's a forest. Okay. So that was the idea. Perfect. So after that. I think, okay, now I think whatever you mentioned, I wrote. Now we have other techniques like what's called as a dimensionality, reduction techniques, right? There are various techniques. If your data set is multi-dimension, you bring it to a lower dimension so that the computational requirement is reduced. Okay, so anyway, where they are there, but anyway, I think that was not there in your syllabus, so it was not dealt over there. Okay, so it's okay, fine. When it is required, if it is required, you can study. Otherwise, just know that there are something like this. Followed by you have what is called as a gradient boost algorithms. Okay, I'll write gradient boosting algorithms. All right. So again, these algorithms are basically going to deal with how quickly the gradient boosting increases the learning rate of this. Okay, so whenever you have to increase the performance, you want to make the machine to learn very quickly. Okay, so as and when you say that I want to increase the performance, right, by uh, increasing the fast. So how to speed up? All right. So if you want to do that, then then you are supposed to go ahead and use the gradient increasing algorithms for that. Okay. All right. Then followed by, let's go ahead. Uh, okay, let's go into the second case, which is a deep learning. All right. Okay. So that was all about machine learning techniques. Then now I'll move on to the deep learning. Do you have any idea what is deep learning, or what is the basics of deep learning? Anything have you come across, maybe in any subject, or maybe at the end of machine learning they just introduced you to deep learning or something? Okay, 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 okay. No problem. Anyway, deep learning is actually a new concept. We cannot expect anyone to know about that in detail or something. Okay, absolutely fine. So now my question is, okay, what you came across, neural networks, right? So can you brief about that? What's there in the neural network? What was the introduction given to you towards neural? Right. Hmm. Right. Uh, okay. Okay, okay. See, the name says that it is neural, right? So neural should suggest you something. Neural is where maybe in biology or somewhere you studied the neural part, right? Where is the neural word coming from? What is the origin of the word neural? Uh, okay, okay, fine, fine, no problem. See, the the neural word is related to brain, correct? Brain cells are neural cells, right? And the smallest, what you call, the cell inside the brain is actually called as a neuron. Neuron. So actually, deep learning is, as you told, it's a advanced NL, neural networks, right? So now I give you an introduction, saying that what exactly you are going to do over there and how, because this is our main objective. So the machine learning is actually older techniques. We are not using any of the machine learning because this already has been used. There are so many algorithms, right, existing, and many people are working over it. Okay, and they are already proven that, okay, you using a machine learning, you get a good result. Okay, it's already proved, so nothing new to prove over there. So in our project, our intention is to, right, use any of the deep learning techniques, so that you can show that, okay, whatever that has been done in the machine learning case can also be done using the deep learning case. Okay, that's all. Okay, coming up now, the neuron is the smallest cell of a human brain, correct? Brain cell. So what happens is, let's consider the structure of a neuron. Okay, so neuron will look something like this. Okay, so the neuron will actually take the this is connected to the other neurons. All right, every terminal is connected to other neurons, so they will pass the information to this cell through these parts. Anyway, the biological name is not needed. Okay, now there is actually a cell structure like this at the center, which is the central part of the neuron. Neuron will process the data that is coming from all the previous neurons, and it will actually pass to the next neuron. So this is the neural part. Now you can have actually another neuron somewhere, maybe that's like to the right. Okay, so now let's say you can actually have another neuron that is present over here. Maybe you can have a neuron just like here. You can also have another neuron over here. Okay, this is how the brain cells look when you go for when you actually zoom in a lot. Okay, zoom in by maybe 1,000 times or 10,000 times, you see like this. So this is connected to this, right? Again, you have multiple connection to this neural. Again, this is also connected to this. So again, there may be other connections as well, like this. Okay, now you can see the basic idea is that somewhere you have this, you pass the information to the next, right? whatever information you pass, right, that will be processed by individual cells. Again, they will be passed to the next. All right. So this architecture is the basics of neural networks. So in the neural networks, what happens, I'll tell you, right? So when it comes to the neural networks, right, you have let's like the basic neural networks. So you have three parts. Okay. First part is called as the input, right? Input is given, taken from input is collected by the neural networks, and that part of the neural network is called as the input layer. Okay, this is simply an input. Okay, the input followed by the weight. Okay, weights also supported by another value, it's called as a bias. Okay, and the third part is the activation function. Okay, now let's see how to represent that. So the neural network, let's say this is the part of the neural network which performs the calculation. Now this takes the input given, right, like the previous layers. Like if you compare this with the, this is how it's, you can relate it, right? We have something like this is the brain cell, and it actually collects, let's say, two inputs. So that's what I am showing here. This could be x1, x2 are the two inputs. Okay, now the inputs, after inputs, you can see that there is an input layer which I already have written at the top. So input layer is the input values. Okay, after the input values, now you need to have the weights and the bias. It's the next component. So weight will be multiplied with each of the inputs. So w1 x1, w2 x2. Okay, that's what will be collected by the neuron. Neuron also takes a third input called as a bias. Okay, now it is going to generate a value z at the output of this neuron, which is the representation of all the weights and the biases. Okay, now this is what is going to come, but this output may not be the required format, right? Required format of output could be something else. So you use what is called as a sigma. This denotes the activation function to generate y. Y is the output which is given to the next neural networks. Okay, so this is how it is representation. The representation is like this, but again, we can relate this to the actual neuron which we have written, right? This actually generates some function, right, through its output terminal, but again, it will pass through this, but before it is given to the next neurons, you have something happening over here. Maybe the magnitude will change, right? Maybe the composition will change, right? Something will happen over there. That's what is denoted by the sigma. Okay, so basic representation of a neuron, right? In the sense you are using the typical brain cell to represent this. Now, what's the necessity? Because you have so many mathematical models available, right? So you have already studied, say, different machine learning techniques. There is a good amount of mathematics that is happening. They are very well established. But why should you go for the basics of brain cells to represent something, right? So that will be the obvious question coming up. But before answering that question, let me denote whatever we discussed so far. So the x1 comma x2 etc., whatever you write corresponds to the inputs. Okay, and the w1 comma w2, if you write like this, these values are called as the weights, right? Each of your input will be weight, there will be a weighting function. It will weighted by these values, x1 into w1, x2 into w, x2 w2, x3 w3, and so on. That's why they are called weight. So you use a b as the bias. Okay, bias is used to push up your result by a specific amount or push down the uh, amount by result by certain amount. Okay, that's why it is called as a bias, right? You can give a positive bias if you want your If you want to push your results towards the positive side, you can use a negative bias if you want to push it down by a specific level. Okay, so like that, the biases are used for that. Then followed by the biasing, then you use what is called as okay, I think we have a z, right? Z is right. The z is equal to, it's a partial result. Partial result calculated as z is equal to w1 into x1 plus w2 into x2, so on, plus the bias. Okay, now you see that bias comes into picture. If you make this as a minus negative value, minus 10, what happens? All the values w1, x1, w2, x2, everything will be added, and you subtracted 10 from that. You are bringing your answer towards negative, closer to the negative. Whereas if you keep the bias as plus 10, you are actually pushing, you are introducing more positiveness in the answer. Okay, that's why this is good. Then the sigma is denoted over there. It actually represents what is called as an activation function. Right? So the activation function is used to truncate your final answer, like y is equal to sigma of z, right? So you have a z that is coming up, right? As a result, this z goes as input to this block where you apply sigma to that and you get a y as output. So z is equal to the application of sigma to that z, right? So you see you are doing this. Y is equal to sigma of z. This is actually called as the output. Right. So in order to design a very simple network like this, right? In order to design a very simple neural network, this is a single neuron. All right. One single neuron is itself is capable of solving many of the problems. Okay. Our one single brain cell is so efficient that it actually solves a lot of problems. Okay. By doing trial and error and medical research, they already have proved this point. Okay, so now I try to answer the other question, that why do you need this kind of representation when you already have others? Okay, so the answer is like this, right? See, the ultimate thing is that, anyway, let's go back to the drawbacks of machine learning first. Okay, so I asked you a question. You studied few of the machine learning algorithms, and what do you think? Will there be any drawbacks, or if anyway, there will be drawback. I cannot say no drawbacks because no algorithm is perfect. Okay, so I'll ask you a direct question. Please think about the disadvantages or the drawbacks of machine learning that you can think of. Okay, can you answer any of the disadvantages that there might be present when we say, okay, I'm going to use a machine learning technique? So until and unless you have some problem, you don't go ahead with the new thing, right? So definitely there has to be some problems. Okay, just think about that. You take your time, no issues. Okay, yeah, just think about that. So the whole process of machine learning, I already have explained. You have to have some. So you collect the data, you split the data into training and testing, then you perform the training, right? The data model is obtained. To that you give a testing data, right? And the testing data will be processed by the machine to give a classification, saying that yes, this is a table, this is a chair, etc. Hmm, hmm. Okay, okay. Possible, but that will be there for every algorithm, right? Not specifically for machine learning only, right? So it's a right answer, but Maybe, right? Something like this is something very general. What you told, it's right, it's correct, but it is general. Can you think of any specific related to specifically any machine learning algorithm, specific machine learning? Hmm, 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 hmm. Okay. Anything else? Okay, it's related to the data itself. You are close to the answer. Maybe you can try to fine tune that. Okay. Hmm. Okay. Okay. So ultimately, you see that you are coming towards the training part, correct? Right. Okay. So let's look at the human brain now, right? So let's assume that there is a newborn baby, right? Brain is just evolving, correct? Right? It actually that small child does not know how to speak, does not know how to recognize, right? Does not know anything, right? Because the brain is not trained, correct? But as the time progresses, you see that nobody will teach the child how to walk, right? It's going to gain that knowledge by itself. Maybe it's going to try to stand. Maybe it depends. All it also depends upon the physical strength of the child. Some children get up maybe 6 months. Okay, maybe somebody will take 1 year, somebody will take 1.5. So there is a difference. Okay, let's neglect that part, right? If the physical strength is good, right, child will try to sit as quickly as possible, then it will try to stand up as quickly as possible, then it will try to walk as quickly as possible. Now you see who is going to do a training over there. There is no training happening, correct? Right? Nobody will teach the child that, okay, this is how you stand. See, the machine learning algorithms require training, saying that, okay, this is chair, this is chair. You give 10,000 images saying that this is chair to the machine. Okay, you give 10,000 images of table saying that this is table, this is table, this is table. Like that, you train the machine. Then only the machine is capable of, right, right, classifying them. But you look at the concept how the brain evolves, right? There is no training, correct? It learns by itself, right? So now you see the huge difference that is going to come into picture when I shift from machine learning into deep learning. Because in deep learning, as I mentioned, the basics, right, is human brain. So when I say human brain, now I think the picture is very clear to you. There is no ultimate goal is that you have to build an algorithm, build a whole idea of human brain in such a way that no training is required at all, right? So you are actually eliminating whatever problems you mentioned earlier, right? You told part by part. Maybe there is a complexity in the data set. Maybe, right, it will the overload the right uh, whole process of training, etc. So many valid points you mentioned just now, right? So look at the broad sense. The broad sense is nothing but it is clearly saying that you don't have to do the training at all ultimately when the whole deep learning concept evolves ultimately. Now still the deep learning is under research, right? So we are not at achieving that point of no training, okay? But look at the uh, when you want to do a straightforward comparison between the machine learning algorithms and the deep learning should tell you that no training is required because we are following how the brain has evolved, right? So brain evolution is something we are trying to model mathematically so that whatever the brain learns, the machine should also be able to learn. Are you getting the point? Yes. So the same example which we just consider, we'll look at that once again. So you see how a child learns. Maybe the example is it may be to speak, it may be for speaking, it actually takes some inputs, right? So whatever the father is talking, whatever mother is going to talk to the child, etc., will be taken as input. But when the child produces same thing orally, there is no input. Okay, so when the child talks by itself, how the child identifies and learns the language, you have to give some inputs. Okay, that is a case where you take input. See, the deep learning also has some aspects which will take the inputs. Okay, right? It's not that you don't take any input to the brain, but some part of the brain will work automatically, like how to stand up, how to walk, how to balance. These aspects nobody will teach to the child, right? Even if they teach, until and unless the brain catches that perfectly, until and unless the brain models that perfectly, it's not going to work. Correct? So you may hold the hand and you may walk with that sometime, but how to walk alone, right? How to walk by itself, the child learns, right, at an appropriate time by itself. Okay, hope that is clear, right? So now I'll come to the second point in the same example. So let's say the child is actually able to stand up and the child wants to walk. What happens? So you might have seen, right, in many videos or maybe with your relatives, the child will keep the first step and then it will fall, right? It falls. Okay. Then once again it will stand up. It now it knows that okay, I have to keep a leg right to the front. So whenever it keeps that, now maybe it will learn how to balance for the first step. Then the second step, once again it will fall. Like that. You see, it will make some mistake. So there is no training. Directly it is going into the testing phase. So this is what is a derivative. I'm trying to relate it in such a way that the concepts related to the deep braining comes, you are going to catch that. Okay, so that's why. So you see, there is no training I mentioned and you are okay with that. Okay, that's fine. But will there be a testing is the next question. When there is no training, what is there to test, right? So this is the point in deep learning, which is the ultimate goal to be developed when it comes to the final stages of deep learning. It is expected that there is no training part and directly the algorithm begins with the testing, because the child is not going to study how to walk. There is no material given to that, no inputs. Automatically it will start walking. So that is the direct testing phase. Okay, so you enter into the testing phase, you make mistake. In the sense, when the machine doesn't know which is a chair and which is a table, right? Maybe it will give an answer at random. So first initially, see, I have a machine, I have a deep learning model with me, right? I have not trained that at all. Directly I'll put for the testing phase. I give a testing, first image I'll give as a chair, let's assume. Okay, when you give a testing image as a chair, now if the machine knows, then only it will tell that okay, this is a chair or this is a table, right? Now what happens when somebody does not know what is it, right? And there is no option saying that I don't know, you have to tell one of them. Means how do you tell? You don't know what is the answer, you don't know what is a chair, what is a table. I am going to ask you that, okay, identify this object. I show you one image and I'll ask you that identify this. right? And there is no option saying that I don't. Okay, so then what you do, you will randomly say that either chair or either table. Correct? Definitely that's the case. So when that happens, you see, right? It can be correct or it can be wrong. Right. Now you see, during the testing phase itself, you can make the machine to learn, correct? If you say chair and this is a chair, I'll say yes, that's correct. So you see that you learn something. It's a testing phase, but still you learn, right? Okay. And the given image is a table, and but you told as a chair. Still you can learn. I say that no, it's not a chair, it's a table, right? Then also you learn, saying that okay, that was a table. This is how the table looks like. So, right? So the concepts of deep learning are completely different from the machine learning, and right, ideally speaking, there should not be any training. You directly start with the testing, and during the testing itself, you will teach the machine saying that okay, this is what is right, this is what is wrong, and these are the various classes that might exist over there. Are you fine with that? Okay, so deep learning is that aspect. Okay, so where ideally speaking, right now we have not gone to that stage. Deep learning is still in the development process. So if you do a project on deep learning, that has to be considered, or that can be considered as the most latest topic. Okay, the most recent project that one can do right now is deep learning concept. Anything on deep learning, because deep learning is not completely evolved. All right, so you are trying to be a part of that in the evolution process. Okay, right. So deep learning is fine. Now I'll tell you how the deep learning, uh, how we can try to develop the deep learning concepts using the neural networks. All right. Okay. So single neuron we define, and a single neuron has what all various parameters that also we have seen. Okay. Right. Now, let us say I want to, okay, now let's go to another simple aspect. Now, when you say that you have a neuron with this, and how can we justify that this neuron or the neural network architecture can be used to solve any problem in the world? Right? Because now we know that neural networks can be applied for image processing, speech recognition, or any radar classification of radar signals. Many things, right, can be done. But to start with, if somebody does not know what is a neural network, how do you convince them that yes, you can use neural network to solve a complex problem? Okay, any complicated problem can be solved by using neural network. How do you justify? Okay, that was my question. Can you try to answer that? Right, I think we have studied the similar answer for maybe in a digital circuit when I taught you the digital logic, right? So any complicated circuits can be drawn using basic gates. How do you confirm, how do you justify that? And or and not, right? Right. So the idea is very similar here, right? So you want to build a very complicated algorithm using neural networks. You simply show that the neural network can, right, can be used to can be used to implement AND function, NOT function, and a OR function. Because already it is very well proved that any circuit, any complicated function can be right implemented by using the three basic gates. Correct. So if you show that okay, neural network can develop those three gates, using the three gates you can develop anything further, because that's already proved. You don't have to prove that once again, right? So right, we actually there is a proof. You try to do a research on this in the upcoming week from the internet, and you try to this is the job I'm going to give you. This is a homework for you. Okay, implement the basic gates. Right? So basic gates refer to, I'm specifically referring to and the or and the not gate. Okay, functions. Okay, so these three functions you need to implement. Now the question is not in general, it is specifically using ANN, artificial neural networks, right? So anyway, ANN, anyway, you have been introduced to that, what ANN is, how many things are there, what are the various components you can use, everything you already know that. So I expect you to, anyway, you don't have to design anything, just search the internet, get the answer and keep it ready. So we'll discuss that in the upcoming class for this. That's the first thing I want you to. Okay, right? This is a homework part anyway. Okay, so the question is clear, right? Okay, now, so let's move on. So we know that now, let's assume that we have implemented this. All right, directly you get the answers in the internet, right? How to implement AND gate, NOR gate, and NOT gate. In addition to this, you also will get the answers for implementation of a NAND gate, NOR gate, XOR gate, XNOR gate. Everything can be implemented using the artificial neural networks. Okay, right? So that's what is the required concept to show that you can implement any complicated algorithms using neural network, correct? Because you implement and not and nor means you can club them together to get a complicated function, right? In the digital logic, you already have proved that, right? So same thing can be derived now by just proving that you can implement these three basic gates or basic functions using the neurons, right? Okay, let's say that you have proved that. You prove that, okay, we are going to implement the functions like this. Okay, once that is done, right, now it is very clear that I can implement any complicated function or any complicated algorithms by using the neural networks. Okay, all right. So let's look at the basic structure of a neural network. Okay, when it comes to the basic structure of a neural network, the inputs, there may be several inputs. Previously, I just showed you two inputs, but multiple inputs may exist, okay, in the given neural network. So these are the various inputs you are going to provide to the neural network. All the inputs are collected by uh, certain set of neurons, and they are the whole layer of neurons corresponding to these inputs are called as the uh, input layer of neurons. Okay, they will simply collect the inputs from the maybe the previous neurons or from the outside world. Okay, once the inputs are collected, the inputs are then processed by another layer of neurons which contains maybe starting from just two neurons till 1,000 neurons. It can have so many. That's the size? That's why I'm writing a very big shape over here. Okay, so this is called as the hidden layer. Hidden layer could be first layer, second layer, third layer, fourth layer, dot 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 dot. I can have 100 layers or any number of layers over here. Okay, that is the hidden layer. I can write layers. So many layers could be present over here. In a sense, whatever is collected from input will be passed on to the hidden layer. And the hidden layer will ultimately generate the output, right? Right, and that output will be converted into the specified format by what is called as the output layer. So output layer will produce the number of outputs as required. So there is no relation between the number of inputs and the number of outputs. So inputs could be 10, output could be only 2. Input could be 100, output could be 10, right? Like that. So they produce the outputs. Okay, so this is the very basic what you call neural networks architecture. It's going to be like this, right, for any uh, neural network that we are going to design. Okay, now, so after this, now let's come to the difference between. So we already mentioned that this is a neural network and the deep learning concepts are derived from the neural network. Okay, so when we say that, then I need to differentiate what is a simple neural network and what is a deep neural network. Correct? So if the number of hidden layers is actually that hidden layers is less than or equal to 2, this is the resulting architecture is simply ANN. Okay, but if the layers are actually more than 2, right, then it is called as a deep neural network. So only that is a difference. Very simple. I'm trying to keep it as simple as possible. Right? In the same above architecture, what we have drawn just now, correct? Keep the hidden layer size just either 1 or 2. Then that is the basic structure of a neural network, right? You can call it as you are using the concepts of neural networks. Okay, but if you increase the size more than 2, 2, 3, 4, so in the sense 3, 4, 5, or 100 or 10, 10,000 or whatever, right? Any number you can use, no issue. Okay, so that will be called as a deep neural network. So the concept that you derive after making the number of hidden layers more than 2, right, will be considered as the deep learning concepts. Okay, so again, to start with, right, since the deep learning concepts are still in the basic phase only, right, even the companies are doing the research over there, everywhere it is still in the right basic phase only, it's in the introduction phase only. Nobody has evolved till a phase where no training is required, directly testing phase. Okay, that is not there, that's not done. So though that is your ultimate goal, now for even for our projects, right, we will be using the concept like there will be a training phase and then there will be a testing phase. Okay, but the ultimate goal you understood, right? So when the deep learning concepts will be completely evolved, people expect that there will be no training at all, directly the testing phase will begin. And see, you will not train. So brain cells are, we understood that brain cells are capable of doing and or not and some basic functions. Only that brain implements classification of table and chair, father and mother, right? The tones will be identified by the child, right? Whenever it is 2 months or 3 months year old, it is able to, right? You see, it can do a lot of job without any training, correct? So the brain of that child, which is basically able to perform the simple operations like and, nat, no, and, not, nand, nor, or something very basic gates, right? Basic functions, it is able to perform uh, fantastically, right? Because it is able to classify so many things, so many signals around in the environment, right? So the idea is that, right, without giving any specific algorithm to the neural network, right, in the DNN concepts, when it completely evolves, it is expected that you don't specify any algorithm, no algorithms to be specified. You don't say the machine that, okay, learn using SVM. No, not required, because machine should know, right, what is the optimum algorithm it can use to classify. Because you don't teach child that, okay, apply this, then you classify, this is the father's voice, this is the mother's voice. No, right? See, brain learns automatically by itself. Which algorithm to be selected, machine knows, machine should know. That is the goal. Ultimate goal is no training, no algorithms, right? See, that's the broad class of what is called as deep neural network, deep learning.